Zumwalt, the U.S. Navy's great stealth destroyer, made history. Can a huge surface destroyer be considered stealthy, armed with Tomahawk missiles, deck-mounted guns, sensors, antennas, and onboard heat-generating electrical power? Sure, the tall, vertical masts, hull-mounted sensors, and protruding antennas could never make for a low observable ship. However, accomplishing these missions is the technical starting point from which engineers set out to build a ship. Stealth warfare is the first of its kind. Zumwalt, stealthy surface destroyer. The sleek-looking Zumwalt destroyers have been designed with a suite of state-of-the-art technologies, including, among other things, massive high-speed computing throughout the ship, smooth and rounded stealth configurations, wave-piercing tumble-home hulls, and electric propulsion. Perhaps most importantly, the state-of-the-art Zumwalts will also receive hypersonic weapons in 2025, a development that could change the paradigm and position them for massive open-water maritime warfare. The Zumwalt destroyer fleet, while reduced to an order of just 3 Zumwalts due primarily to cost, is designed to appear like a small fishing vessel to enemy radar. The Zumwalt's hull is smooth and rounded, with few sharp edges or angles that could generate a return signal. The lack of vertical structures and protruding shapes, such as huge deck-mounted cannons, reduces the number of conceivable shapes that could ping or return enemy radar signals. This increases survival chances. Although it is highly unlikely that a destroyer as large as the Zumwalt will not generate any return signal to enemy radar or sonar, its setup seems designed to produce a rather different image than it actually is: confuse enemies. This concept aligns with the intended effect of the Air Force's stealth fighters and bombers, designed to look like an airborne bird or insect to enemy radar eyes. Different design. If we look at the Zumwalt's external shape, the ship lends itself to a debate on some of these fundamentals regarding stealth properties. First of all, compared to other surface ships, the shape of it is, of course, totally different. There are fewer edges, a conspicuous absence of protruding structures or variegated contours, and a flat side, perfectly attached to the ship's upper deck, on a straight, though slightly angled, flat linear surface. Instead of multiple panels and sharp, interlocking steel structures supporting an outward-facing radar system, the Zumwalt's frontal exterior shows only a few rounded edges to achieve its required shape. Her controversial wave-cutting tumble-home hull is narrower than that of existing destroyers, making her less detectable to enemy sonar. Stealth destroyer details. Differently shaped external structures, with sharp angles, pointed edges, and spreading vertical designs, naturally offer many more areas for radar pings to bounce off. Low observability, by extension, occurs when the radar has fewer return electromagnetic pings with which to create a representation of the object. Since electromagnetic pings travel at the speed of light, a known entity, and the travel time can be determined, a computer algorithm can determine an enemy object's shape, size, and distance if there are enough signals to return. Acoustic pings work within the same conceptual framework, simply using sound instead of electricity. Consequently, the Zumwalt engineers tried to build a ship capable of evading radar and sonar detection. Thanks for watching.